Number 6, I do not understand how the magnetic fields of the electrons and the other nuclei in the vicinity of the H atom means the chemical environment of the nucleus. Could you please explain, or could you please elaborate that?
Okay. So why, let's see.
I do not understand how the magnetic field...
How that means that. Okay.
Yeah.
So this is, it, in the answer choice, when it says the chemical environment of the nucleus, it's meaning what other atoms and elements are around it, because that's going to affect the magnitude of the field that's produced there. So in the passage, when they say B3 is the vector sum of the magnetic fields of the electrons and other nuclei in the vicinity of the hydrogen atom. So the electrons and other nuclei, those are the chemical environment surrounding the hydrogen nucleus that we care about. And kind of what this means is that if you have a hydrogen atom surrounded by other hydrogen atoms in water, then all of those hydrogen atoms in water are going to interact differently than if you have a hydrogen atom on a protein surrounded by other hydrogen atoms and other molecules bound in proteins. And those are just going to make very slight differences in the magnitude of B3 that can be exploited and used to create contrast in this MRI. So if you didn't kind of immediately think, whenever you see this sentence, that that means the chemical environment of the nucleus, you could look at the other options, which are mass of the nucleus, radius of the nucleus, or charge of the nucleus. And we know that none of those are mentioned as being important to B3. The mass of the nucleus is really not mentioned or discussed at all anywhere. Neither is the radius or size of the nucleus. The charge of the nucleus is also not mentioned. The thing that they care about is the net spin of the nucleus, but not kind of the overall charge itself. Okay, so this is the best answer because it's the closest to what they tell us in the passage. Any other questions?
Yep, we got another one. On question number 10, I think, obviously I don't have it in front of me. Does precision frequency always mean net spin for our purposes? I would not have put those two terms together without hearing your explanation. Was it in the passage and I missed it?
Let's see. Okay, so see what we have about that. 9 and 10. Okay, so the kind of the way we get between these things, the question is saying for a given magnitude of B1, so B1 equals constant, so it's not varying. The nucleus with the non-zero precession frequency will be which of the following? Okay, so precession frequency is this omega d, also called the angular frequency, because they tell us that, see, it's in the 3rd/4th paragraph, where it says, if mu is parallel, the hydrogen nucleus will precess at an angular frequency, omega d. So that's what they mean when they say precession frequency. And they give us the equation for it, which is 4 pi mu beta 1 over h. Okay, so we want to know which of these answer choices is the angular frequency not equal to 0. Okay, so the B naught is constant. It can't change. Planck's constant h is also constant. And 4 and pi are constants. So the thing that can change here let me